Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over the law of definite proportions. So in the last video I went over the law of conservation of matter or mass, and that was discovered or proven by Lavoisier around 1789. Um, and so now we have Joseph Proust comes on the scene, and he looks at the data in a different way. So just like with Lavoisier, he was looking at how the masses of the reactants is equal to the masses of products at the end of the reaction. Proust took it a different way. He was looking at the ratio of the masses of the elements that are produced from the compound. And he noticed something interesting. And that is that all samples of a given compound, regardless of their source or how they're prepared, have the same proportion or ratio of their constituent elements. So, what does that mean? It means that no matter how much water you have, right, or where it came from or how it's made, if it really is water, then what will happen is you can break water down into its elements, and then the mass ratio of the elements will always be the same. The ratio doesn't change. And so here's an example, right? So here I take 18 grams of water, and it doesn't matter where the water came from. It could be water on Earth or water on Mars. It doesn't matter how it was made. It could have been made naturally or in a lab. So as long as it's water, if you take a certain amount, let's say 18 grams, and I can break this down into its elements. And if Lavoisier was looking at that, he would say, oh, look, 16 grams of oxygen plus 2 grams of hydrogen gives me 18 grams total on this side, which is the same as this side. So 16 and 2 is 18. That equals 18 here. So that supports the law of conservation of mass, right? But Proust was not really interested in that view or that um, part. He was more interested in the ratio of these two, right? So he compared the mass of one element to the mass of the other element and looked at the ratios. And so, for example, in this example here, I have 16 grams of oxygen and 2 grams of hydrogen. I put that as a ratio, and I find that the mass ratio of oxygen to hydrogen is 8 to 1. And here's the amazing thing: this ratio will always be 8 to 1 no matter how much water you have, right? So if I have 30 gallons of H2O and I break that down into hydrogen and oxygen and get the mass ratio, I will still end up with an 8 to 1 ratio. And so that is what the law of definite proportion says. Here is another example. Here I have NH3. NH3 is ammonia. And so in this example, I have 17 grams of ammonia, and I break that down and I get 14 grams of nitrogen and 3 grams of hydrogen. Again, you could see that mass is conserved. So Lavoisier would be looking at that. Oh, look, 14 plus 3 is 17. That equals this side. Mass is conserved. But again, Proust is more interested in the ratio of the masses of the elements formed. So you put that in a ratio, 14 grams of nitrogen over 3 grams of hydrogen, and you get a ratio of 4.7 over 1. And again, that ratio will always be that ratio as long as what you have is ammonia. So if I have 30 grams of ammonia or 30 tons of ammonia, if I break it down into its elements, the ratio of the masses of those elements will always turn out to be 4.7 to 1. And that, ladies and gentlemen, is the law uh, of definite proportions. Definite meaning that the proportions don't change. That's what definite means in this case. So constant or same proportions. So basically, the ratio of the elements that you get from the compound that you are breaking apart will always have the same mass ratio. And again, this makes sense because for those who were looking to support the atomic theory that all matter in the universe is made up of atoms, these indestructible particles, this fits and supports or is consistent with that theory, right? Because if you look at here, so if we have water and water is made up of atoms, two hydrogen and one oxygen, right? The ratio of the mass, the ratio of these two are constant. So you'll always get two hydrogens for every one oxygen. So if the number of hydrogens and oxygens, or the number of atoms or of each type of atom in your compound is consistent, then that means the masses are going to be consistent and the ratio of the masses is going to be consistent. So the ratio of the atoms is always going to be 2 to 1 for water. If the ratio is not 2 to 1, it's not water. So that makes sense. So the atomic theory is supported by the law of definite proportions. So I hope that makes sense. If you learned something from this video, if you enjoyed this video, if this was in any way inspiring, then please, by all means, like the video, share the video, hit that like button over there, and then make sure you subscribe to my channel and hit that notification bell. When you do, make sure you click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me and have a great day.